Hello everyone, my name is Yusuf El-Kio, and today I will be discussing my second paper, just going through a research paper that is aimed to address critical gaps in first-generation serverless computing. So the paper is titled Serverless Computing, One Step Forward and Two Steps Back. It was written in 2018 by 8 researchers named Joseph Hellerstein, Jose Faleiro, Joseph Gonzalez, Johann Schleier-Smith, Vikram Sreekanti, Alexey Tumanov, and Chenggang Wu. So what exactly is the problem? The problem is the paper talks about how there are gaps in first-generation serverless computing, and these gaps essentially place the autoscaling potential at odds with dominant trends in modern computing. These gaps make current serverless offerings a bad fit for cloud innovation, and particularly bad for data systems innovation. So the paper talks about FaaS as an example of one step forward and two steps backward issue. FaaS meaning functions as a service, which is a type of cloud computing service that allows you to execute code in response to events without the complex infrastructure typically associated with building and launching microservice applications. So as part of the research paper title, Functions as a Service is a big step forward for cloud computing by offering manageable and seemingly unlimited compute platform, but it is also 2 steps backwards because it ignores the importance of efficient data processing, as well as it hinders the development of disturbed systems. So why is this still a problem? So the cloud offers 3 key features. Firstly, unlimited data storage. Secondly, unlimited distributed computing power. And finally, the ability to harness these, but only as needed, paying only for the resources you consume, rather than buying the resources you might need at the peak price. Now you see, serverless computing takes 1 step forward and 2 steps backward from this because it realizes that there is a potential of paying as you go service, like a paying as you go. However, FaaS offerings restrict the ability to work efficiently with data or distributed computing resources. The research paper lists 4 reasons to why this is still a problem. Firstly, limited lifetime. So after 15 minutes, usually, functions and invocations are shut down by the Lambda infrastructure. Therefore, the program must be constantly running in order to stay on. Secondly, input-output bottlenecks. So Lambdas connect to cloud services, notably shared storage, across a network interface. This typically means that moving data across nodes or racks. So with FaaS, things appear even worse than the network topology would suggest. So the studies shown in the paper show how that a single Lambda function can go on to achieve around 538 megabits per second network bandwidth. These are obviously numbers from Google, and we're in the same ballpark. This is basically just an order of magnitude so much slower than a single modern SSD. So this is just showing how input-output affects in a way, which is why this is still a problem, why serverless computing is kind of a problem. Thirdly, the third reason to why it's still a problem is communication through slow shortage. While Lambda functions can initiate outbound network connections, they themselves are not directly network addressable in any way while they are running, and therefore 2 Lambda functions can only communicate through an autoscaling intermediary service. And finally, there is no specialized hardware. FaaS offerings today only allow users to provision a time slice of CPU hyperthread and some amount of RAM. So the related work, one issue with this paper is that there was no related work that was mentioned, and that was pretty surprising. Instead, there was experiments that were done prior to the paper research, proving the point of serverless computing being a 1 step forward and 2 step backward design. One of these experiments was an application on Lambda that pipelines batching work done by SQS with a trivial classifier running in Lambda functions. And the application accepts batches of text documents, uses a model to classify each word in the document as dirty or not, and writes the document out to a storage service with the dirty words replaced by punctuation marks. The speed was measured and was seen to be relatively slow in terms of latency. So the main idea, obviously the researchers writing this paper focused on how to prove the serverless computing is not an ideal solution. The researchers go on to explain the problems with functions as a service, as previously mentioned. What can be done? The researchers for this paper describe how important cloud programmers need to be able to harness the compute power and storage capacity of the cloud and autoscale in a cost-efficient manner. They believe that in order to achieve this goal, it does require a programmable framework that goes beyond FaaS to dynamically manage the allocation of resources in order to meet user-specified performance goals for both compute and for data. The paper then discusses 3 key challenges that need to be looked at in order to achieve a programmable environment for the cloud. So the first one being fluid code and data placement. To achieve good performance, the infrastructure should be able to physically collocate certain code and data. This is often best achieved by shipping code to data rather than the current FAAS approach of pulling data to code. Secondly, heterogeneous hardware support. Cloud providers can attract a critical mass of workloads that make a specialized hardware cost-effective. Cloud programmers should be able to take advantage of these resources. And finally, the security concerns. Cloud programming obviously brings up both opportunities and challenges related to security. Cloud-managed software infrastructure shifts the onus of security onto a small number of well-incentivized operations staff at the cloud provider. So it is obviously important for researchers and developers to think about not only to the preventative technologies, but also ways to guarantee auditing and post hoc security analysis. So the evaluation for this paper that was done, case studies have been set up to prove issues of serverless computing. So one of the case studies is that it explores the AWS Lambda's performance for a common data intensive application. In this case, it was a machine learning model training. It suffers dramatically from the data shipping architecture of Lambda. The model was running the model was basically running a TensorFlow neural network model to predict average customer ratings. So the model was trained in Lambda. It took around 3.08 seconds for one iteration, 2.49 to fetch a 100 megabyte batch from S3, and 0.59 seconds to actually run the model. The Lambda function times out at a 15-minute limit after 294 iterations of this algorithm. The model was trained over 10 runs of the training data and ran for around 15 minutes at $0.29. The same model was trained on EC2 instance, and the outcome proved that running the model on Lambda is 21 times slower and 7.3 times more expensive than running on EC2. Now, to critique, the main issue for this paper was that there was barely any infographics for the readers to refer to when explaining models and charts, and that was a major letdown for me. Secondly, I do feel that the paper is pushing towards a negative view on serverless computing in a way which is trying to cause a bad view on it, when in reality serverless computing has been proved countless times to be the next step forward for businesses and operations. And finally, I believe that there was not really any concrete suggestions on how to improve the issue of FAAS as being a step forward but 2 steps backwards design. However, the authors should investigate in a way how to solve the issue rather than just suggest it.